We're going to talk about infrared spectroscopy and what we can glean from that spectrum. So you have to think about the bond being a spring, and it vibrates and bends in natural frequencies. So if we allow those bonds to absorb infrared, then we can understand the types of bonds that are in our molecules. Lighter atoms vibrate at a higher frequency. Multiple bonds vibrate at higher frequencies than single bonds. And then the most simple diatomic molecules like HCl, HBr, HI only vibrate in the bond stretching, which means they're not going to rotate or come out towards you because they're just two regular bonds. So they would do what the top row of molecules is showing as opposed to what the bottom row of molecules is showing because they don't have a point at which they can bend at. Bonds will only interact with infrared if it is polar, so it has to be a polar bond, and that's because the delta positive and the delta negative allow it to interact. The wave numbers, or the wavelength numbers, the data is given to you in your data booklet in section 26. When it says intensity, strong means that it should be a sharp peak that goes far down on the graph. Medium, like for the alkenes, means it's a sharp peak about midway down the graph. And then if it says broad, like with our alcohol or our hydrogen bonds and alcohols, that just means it's a wide peak, so it looks very fat on the graph. So for example, we have our spectrum of propanone, and so we want to see where is that carbon double bonded oxygen, and then where would a carbon and hydrogen be. So we can look in our data booklet, and we can see that ketones, which is what propanone is, forms a peak at about 1700 for the carbon double bond, and then this area up here would be our carbon-hydrogen bond. Now down here under 1000, this is also known as the fingerprint region, and we don't tend to look down there if we don't need to. So we're really just trying to pick out different areas of the graph to help us understand the bonds. All right, here's propanal. So we went from a ketone to an aldehyde, meaning the double bonded oxygen is now at the end of the chain. We're on the first carbon. We still have that peak around 1700 that represents the propanal. So you're not always able to tell the difference between two known molecules. You have to have more information than just necessarily the IR spectra. So a lot of times you use the IR spectrum and the mass spec together and the IHD together to figure out what the molecule is. Here though, they gave us 4 options and we can kind of break it down. We have a ketone, an alcohol. Number 1 is a ketone, number 2 is an alcohol, number 3 we have a carboxylic acid, and then number 4 we have propanal. Well, all 4 of those would have a carbon-oxygen double bond, which is why we see that peak at around 1700. So that doesn't really help us narrow it down. However, what we do have is this really broad band around 3000, which indicates a hydrogen bonding in carboxylic acid. So this broad band right here that it's pointing at would represent that this is a carboxylic acid. So it's giving us another point to look at so that we can say, in fact, this is number 3 propanoic acid.